Hi, my name is Nofara Alisa.
Hi, my name is Nurani Shafiqa binti Zamaluddin.
Hi, Assalamualaikum. My name is Dahlia binti Zulkarnain.
My name is Siti Mariba binti Muhammad Rizal.
Our first case study is compound interest, and I'm going to start with Introduction of Compound Interest. The citation of our introduction is from Elvis Picardo, 2025. Compound interest equals the total amount of principal and interest in the future of future value, less than principal amount at present, referred to as prevent value. Compound interest causes the principal to grow exponentially because interest is calculated on the accumulated interest over time as well as on your original principal. Our problem statement for the compound interest is Juwita has a 10-year-old daughter and she had opened an education fund for her daughter at Maybank. She plans to save her money in fixed deposit account, depositing 2,000 ringgit for 8 years. The saving account offers an interest rate of 2.20% compounded quarterly. The first objective is to determine the accumulated amount at the end of Juwita's saving period.
Objective 2, to calculate the total interest received by Juwita. Objective 3, to calculate the account balance at the end of saving period if Juwita added another 1,300 ringgit into the same account 3 years after her initial deposit. Objective 4, to calculate the accumulated amount at the end of saving period if the interest rate changes to 2.45% compounded semi-annually 6 months after her initial deposit.
Before we move on to the calculation, we have to do a timeline. So our timeline started with P and ended with S, which is our accumulated amount. The 2,000 ringgit from our problem statement is our P. Starting from the P, 2,000 ringgit, our K is 2.20% equals to 0.022, and our M, which is our frequency, is 4, and our T is 8 years. Now we need to find I and N. I equals to K over M. Our K is 0.022 and our M is 4. 0.022 over 4 equals to 11 over 2,000, and our N equals to M multiplied with T, which is 4 multiplied with 8 equals to 32. For the first objective, we need to determine the accumulated amount at the end of Juwita's saving period. So for this calculation, we need to use the formula of S equals to P multiplied with 1 plus I multiplied with the power of N. S equals to 2,000 multiplied with 1 plus 11 over 2,000 and multiplied with the power of 32. So the total of our S is 2,383 ringgit 73 cents.
For the calculation in objective 2, we need to find the I, which means we need to use the formula I equals to S minus P. Next, I equals to 2,383 ringgit 73 minus with 2,000. I equals to 382 ringgit and 72 cents. In objective 3, we need to use the timeline from P1 until S. Between the P1 until S, we have another P2, which means an added amount 1,300 ringgit. Our original T equals to 8 years. From P1 until P2, T1 equals to 3 years, while P2 until S, the T2 equals to 5 years. K equals to 2.20%, equivalent to 0.022. M equals to 4, which means every 3 months. I equals to K over M equals to 0.022 over 4 equals to 11 over 2,000. For N1 equals to M T1 equals to 4 multiplied with 3 equals to 12. For N2 equals to M T2 equals to 4 multiplied with 5 equals to 20. For the calculation, we need to find the S1 first. We need to use the formula S1 equals to P1, open the bracket, 1 plus I close the bracket, to the power of N1. Next, S1 equals to 2,000, open the bracket, 1 plus 11 over 2,000, close the bracket, to the power of 12. Next, S1 equals to 2,136 ringgit and 7 cents. After that, we need to find the P new, which means we need to use the formula P new equals to S1 plus P2. Next, P new equals to 2,136 ringgit and 7 cents plus 1,300 ringgit. Next, P new equals to 3,436 ringgit and 7 cents. After that, we need to find the S, which means we need to use the formula S equals to P new. Open the bracket 1 plus I, close the bracket, to the power of N2. Next, S equals to 3,436 ringgit 7 cents. Open the bracket 1 plus 11 over 2,000, close the bracket, to the power of 20. Next, S equals to 3,834 ringgit and 45 cents. In Objective 4, since the interest rate changes to 2.45%, compounded semi-annually, 6 months after her initial deposit, we need to use a different timeline for this calculation. This calculation started with timeline from P until S. The first T, we have T1 equals to 6 months. T1 equals to 6 over 12 equals to 0.5 years, while for T2, we have 7 years and 6 months. T2 equals to 7 plus 6 over 12 equals to 7.5 years. Our original T is 8 years. Since we have T1 and T2, that means we have K1, K2, M1, M2, I1, I2, and N1, N2. K1 equals to 2.20%, equivalent to 0.022. M1 equals to 4, which means every 3 months. I1 equals to K1 over M1 equals to 0.022 over 4 equals to 11 over 2000. N1 equals to M1 T1 equals to 4 multiplied with 0.5 equals to 2. For K2 equals to 2.45%, equivalent to 0.0245. M2 equals to 2, which means semi-annually. I2 equals to K2 over M2 equals to 0.0245 over 2 equals to 49 over 4000. For N2 equals to M2 T2 equals to 2 multiplied with 7.5 equals to 15. For the calculation, we need to find the S1 first, which means we need to use the formula S1 equals to P. Open the bracket 1 plus I1, close the bracket to the power of N1. Next, S1 equals to 2000. Open the bracket 1 plus 11 over 2000, close the bracket to the power of 2. Next, S1 equals to 2,022 ringgit and 6 cents. After that, we need to find the S, which means we need to use the formula S equals to S1. Open the bracket 1 plus I2, close the bracket to the power of N2. Next, S equals to 2,022 ringgit 6 cents. Open the bracket 1 plus 49 over 4,000, close the bracket to the power of 50. S equals to 2,427 ringgit and 23 cents.
T is the sequence of equal payment made at the equal period of time. Insurance premium, one-touch payment, interest payment, on-bond payment of rent. Premium payment on hire purchase and event are a few examples of annuities. The future value or accumulated value of the annuity is the total value of the set of payment at the end of the term. Similarly, the present value or discounted value of an annuity is the equivalent value of the set of payment due at the beginning of the term. Problem statement case study 2. City planned to buy a studio unit at the MERS resident KLCC in Kuala Lumpur. The property price is IM 820,000. She wants to pay a 10% down payment and the balance will be financed through a loan from BSN My First Home. The bank offer an interest rate at 4.60% compounded monthly and the loan will be paid over 35 years. Okay, here for the objective 1, which we want to determine the amount of monthly payment that paid by City.
Next, for objective 2, we need to calculate the total interest incurred by Siti, and for objective 3, we need to calculate the outstanding balance if Siti wants to settle the loan after the 400 payment. And for the last one, objective 4, we need to determine the outstanding areas that must be settled on the next payment if Siti missed 2 consecutive monthly payment.
For this, we have the timeline that have A and R. For A, RM 738,000 ringgit, and we need to find R. This part we have cost price, down payment and balance. Cost price equal to 820,000 ringgit, down payment which 10% multiply CP and equal to 82,000 ringgit, and balance equal to CP minus DP, which we will get 738,000 ringgit. The K equal to 0.046, and for M 12, T 35 years, and I K divide M and equal to 0.046 divide 12 and equal to 23 divide 6,000, and equal to M multiply with T equivalent to 12 multiply with 35, so N is 420. For this calculation, that would be R equal to 738,000 ringgit. Put the bracket, and we need one more bracket for 23 divide with 6,000 ringgit, and divide all the bracket with bracket 1 minus, and put one more bracket 1 plus 23 divide with 6,000 ringgit, and close the bracket and put the power negative 420 and close the bracket. We will get R equal to 3,538 ringgit and 40 cents.
So for calculation 2, we need to find total interest. So we use I equal R in bracket N minus A. I equal to open bracket 3,538 ringgit 48 cent, close bracket, open bracket 420, close bracket, minus open bracket 738,000, close bracket. The final answer is I equal to 748,161 ringgit 60 cents. So for calculation 3, we need to find total outstanding balance. So we use N unpaid equal N total minus N paid. 420 minus 400 equal to 20. So the formula is AN equal R open bracket 1 minus open bracket 1 plus small capital I close bracket the power of negative N close bracket divide with small capital I. So we get A20 equal open bracket 3,538 ringgit 48 cent close bracket open bracket 1 minus open bracket 1 plus 23 over 6,000 close bracket the power of negative 20 close bracket divide with 23 over 6,000. So the final answer is A20 equals 67,999 ringgit 46 cent. For calculation 4, we use an unpaid equal 2 plus 1 equal 3. So we use formula S and equal R open bracket 1 plus small capital I close bracket power of N minus 1 close bracket divide with small capital I. So we get S3 equal open bracket 3,538 ringgit 48 cent close bracket open bracket 1 plus 23 over 6,000 close bracket power 3 minus 1 close bracket divide with 23 over 6,000. The final answer is as 3 equals to 10,656 ringgit 18 cents. In conclusion, based on our understanding, compound interest demonstrates how consistent saving allows your money to grow progressively over time due to the effect of interest compounding on both principal and accumulated interest. Annuity demonstrates how structured loan repayments over an extended period such as home mortgage can be managed effectively by understanding interest rates, payment schedule, and the implication of missed payment. Hence, both compound interest and annuity are important financial solutions that can be approximately impact long-term wealth. By understanding this concept, we can make more knowledgeable financial decisions and build a more secure financial future. That's all. Thank you.